Right, after this one, we're going to do a short break before we go to the last one. You good? You ready?
Yeah.
Okay.
Alright, good evening.
Right, maybe you need louder then.
Okay, I'll try and check the voice. If at any time I'm not an accomplished or seasoned public talker, so if I do start fading, please just give me a signal. I'll try and project my voice a bit better. But the topic I'm talking about is matching in Rust, and it's beyond if else. It's going to be quite. It's going to be aimed at the beginner, basically. There you go. Because I'm quite new to Rust myself, so this is going to be from my perspective, and I hope it's going to help some of you in the audience as well. And if you're a seasoned Rust developer, I hope I don't bore you too much, because it's going to be pretty. Well, we'll touch on some intermediate stuff, but it's going to be quite basic. So just about myself, my background is based mostly in electronics. Previous to that, I started coding when I was quite young. I was mostly doing game dev. So I've quite recently revisited it, mostly because I started studying part-time, doing a degree in creative computing, and also I've got some interests with a blockchain project called Fala Network. It's like decentralized cloud computing. It's pretty close to AWS, but Lambda is the version of it, but a blockchain version, and all their functions, Lambdas, are programmed in Rust. So that's what's driven me to actually switch from object-oriented programming to actually pick up and start learning Rust. So that's my background, that's why I'm here, and yeah, I'm quite new to Rust. So, jumping on to the subject, the role of match, at a bare bones level, it basically replaces a big chain of if-else statements. It's similar to, every time I've come across it, it's a switch statement in languages like C# or Java. That's the same code exactly in Rust, what a match looks like at a very basic level. And that's the alternative, that's a C# version of it. So you can see the Rust version is a bit more concise, but under the hood, and as we'll see as we go along, Rust has got a few more tricks up its sleeve than a standard switch. It's quite powerful, it's very versatile, do some pretty cool tricks with it. So the Rust programming book, famous one, when it talks about match, it gives an analogy of a coin sorting mechanism. And that's quite a good visualization, I felt it was for me. So if you think about all these values that are coming down, they're going to land in certain slots due to the size of the coin and the size of the hole, which would be the pattern. And whatever slot the coin lands in, if you can think that that's going to execute a certain code block. So different code blocks are assigned to different slots, and the size of the coin, or the value, if it matches the pattern, is what determines which one gets executed. So we'll take a look at the signature, what makes up a match statement. And first off, we've got the keyword, which is match. Not much else to say about that. Following on from that, we've got the scrutiny, or the expression, and this is what's going to be compared against the patterns and decide which code block gets executed. So everything's contained in curly brackets, like most things in all languages. And now we've got the separate arms of the match expression. So whatever pattern matches will determine which arm executes the code. So if we take a look at the actual individual arms, on the left-hand side we've got the pattern, and that's got to be compared against the scrutiny. And then on the right-hand side we've got the code that will be executed. In pattern 1 we've got a single line. In pattern 2 we've got colored braces, which means an entire block will be executed. And in between, we've got the fat arrow, or the rocket operator, as it's sometimes referred to. So handy function, it was the first time I'd come across it in coding, is the fact that you can actually return a value from your match expression. I think other languages do support it, but I've never come across it myself. It's quite useful. So as you can see in this example here, the variable result is going to store the result of what is matched. So we've got the number 42 is the scrutiny, and it's going to match the pattern, which is the wildcard in this case, which is going to return the string or the string slice and store it in the result, and we're printing the result. So this is a different version of it. Just to show you how it can be used on like our recursive. So as I've mentioned, it enables like transformation. So you can transform the number you're feeding in, and if you recursively loop it, you can do some quite interesting algorithms maybe. So in this case, a number is going to be matching against itself, and the result of it, as we see here, it's just going to add 10, so it'll be 52. And that takes us on to enums. Enums are pretty much a very basic data type, in all languages. I think JavaScript doesn't support them, but you can get around them with constants, I believe. I'm not familiar with JavaScript. But they're very, very, very simple. But again, in Rust has got a few more tricks up its sleeve, and you can do some interesting things with enums. And they're a perfect partner, especially if you're using them in a switch statement or a match statement. Quite useful to use enums, so you can determine if you're using a state machine or something, you can have your states labeled up with nice, easy to read labels. So in this case, I've got a very simple enum type defined as traffic light, and it's got 3 states, red, yellow, and green. And we assign it to a variable by using the traffic light, 2 colons, and the actual value that we stored. And another bonus with enums in Rust is that you can actually associate values with them, and you can also attach behaviors, attach functions, which is a big bonus. I've never seen that anywhere else before. It makes enums very powerful in Rust. So if we take a look at this enum here, in the brackets you can see that we're associating an unsigned integer with it. So in the example that I'll be giving you, this will relate to the duration that the light will be on traffic. So in this case, we're assigning to the variable the colour red, and it will be on for 30 seconds. So if we use this in an actual match statement, see that the current light I'm assigning is red, it's going to be for 30 seconds. So what the match statement is going to do, we're going to come down each leg and compare them. Whichever one matches is going to execute the associated code. So in this case, it is the first arm. And you can see I've got red, and inside the tuple in brackets, we've got the variable seconds. So the value 30 is going to be transferred into that variable, and we're going to use that variable in code block at the right side of the flat arrow. So the first thing we're going to do is just print line a simple statement that the colour is red, and then we're going to return the value seconds, and it's going to be assigned to the variable duration. So we'll then come out of the match statement, and at the end we're just going to print the remaining time is, and the duration, 30 seconds. So if we make a slight amendment to that, if we add a bool value, if we add it to the yellow colour, and this is going to determine whether or not the yellow line is flashing. If it's false, it's going to be solid, but if bool is true, the yellow light will be flashing. So to do this, we're going to implement a function onto the traffic light enum, and that is simply just going to print that the light is flashing. So if we take a look at that in action, it's pretty much the same again. The scrutiny is going to be current light, which we're assigning the colour yellow. The 2 variables in the tuple, which is then it's a 10 and the boolean true. So that's got to be, means it's got to be on for 10 seconds and it's done to flashing. So that matches with the second arm, and again we've got transpose. There's two values. The first value 10 was the second, and true is transpose, but the value is flashing. So we'll print out the value yellow. We then got an if statement which checks if it's flashing, and if it is, we then trigger the function make it flash. We then come out, we return the value seconds, so at the end we print the duration of the remaining time zone. So that's the output. The current light's yellow, the light's flashing. So there is another way to do that. We don't just have to, what we're talking about is actually reconstruction. We're transferring the values from the top tuple to the variables that were contained in the tuple of the arms. But we can also use that as part of the matching process as well. So in this case, I've got two yellow arms, and the seconds variable is going to be assigned value 10, but the second value, false and true, is already there. So that's got to be used as part of the pattern matching. So instead of being assigned the value, it's being used to decide which one of the two arms will be executed. So because we defined it as false, that means that the first yellow arm will be executed. It's going to print that the colour is yellow, and it's going to return the value seconds, which will be assigned to the variable duration. So that gives us the output that the current light is yellow and the remaining time is 10 seconds, but we didn't trigger the make flash function. So even though that actually looks, to me that looks quite good, it's quite modular, it's quite easy to read, you know exactly what's happening. It's not optimized very well. People like more concise code, like to reduce less code the better basically, so you can reduce it down quite a bit significantly. Because as you can see, I'm repeating a lot of print lines, like the current light color, the current light color, the current light color. We can reduce that by just returning the tuple itself. And this time, for each arm, we're going to return a tuple with two values, seconds, and the string with the color. And at the bottom, we're going to deconstruct that. So from the let statement, with the tuple with two variables and the result, we're now going to extract the two values to the associated duration and current color, which we can then use in the println statement. And that was just to introduce the actual concept of deconstructing, because that's used extensively in pattern matching, and you can do it with pretty much all the types. We will mainly be concentrating on tuples, arrays, structs, but there are many more. But I won't go down that road. It's a bit more advanced. It's a bit beyond me, to be honest. So just a quick example of how we can do it with each one, as we've seen with the tuple. In the previous example, you pack the three values into a single variable, but you can extract them into three separate variables or deconstruct them into three separate variables. The one would go to A, hello would be, and 3.14 would go to C. And you can do exactly the same to an array. The only difference, slightly different change in syntax, we're using square brackets instead of normal brackets. And you can also do it with a struct, and the style of a C term. Structs are quite nice because you've actually got to use the value x. So to assign a value to the x, you use the colon, so x colon 10, y colon 20 means you put 10 into x and 20 into y, and you deconstruct it exactly the same way as you do with the tuple. So we can do some nice tricks with match, just for extracting values from tuples or arrays or different data types. In this case, we've got a data set, in a tuple, 2, 4, 8, 16, 32, and we can use a single arm of a match, so there's no comparison, it's simply just extracting the values. So the 2 will be extracted to first, the 4 will be extracted to the underscore, which is a wildcard, so it just basically means it's being ignored. Basically, think of it as being thrown in the trash bin. 8 will go to third, 16 will be ignored, and then 32 will go to fifth. And then we can simply print them out to show what they are. And another version of that, this can be used with this is a very practical example, but if you can imagine an array with a very large array, you just want the first and the last examples, you can use these 2 dots. So the first value, 2, will go to first, 32 will go to last, and 2 dots signifies a range. So basically everything in between is going to be ignored. So we've got the values 2 and 32. So that's covered everything that I was going to cover, and this is an example that I've seen on YouTube. I thought it was quite a nice example, and it kind of summarises everything that I've covered tonight. So it's quite a good one to come back to. So I've obviously given it the QR code and put this on it just if you want to revisit it. If you haven't understood everything tonight, then if you have understood it tonight, then you'll be able to walk through every part of this and read exactly what's going on. I'll just wrap this up. I'm just going to talk through to say what each part of it's doing. But basically, the point is, if you can understand this or read through each part and know exactly what's going on, you've got a pretty good idea. You're at a pretty good level of matching and Rust. If you don't know, it probably points you in the right direction of what you need to look at. I've introduced a couple of other things in there that I was going to talk about as well. And that is the option, which in itself is a built-in enum. And I'll just wrap it up there, to be honest. So, yeah, that's I'll just wrap it up there.
Thank you. I like the way how you rap. Yeah, you understand that code? Good for you. If you don't, read the documentation.
It's not too advanced. It was aimed at beginners, so if you're struggling to read that, it kind of points in the direction where that was the point I was trying to.
Cool. I'm going to do a quick 30-second break because I need to change, but I actually want to take a moment to talk about matching. Like I was speaking to some folks back in my previous company in Raleigh, we use matching a lot, partly because when you do data extraction on the system we're going to write. Pattern matching was actually quite important for us to make sure the data collection and structure is right. So that's why I think this is a very powerful topic, and thank you so much for covering. Again, for anyone, if you want to talk about matching, feel free, nominate. Yes?
There was something to note. Someone said in the previous talk, he said that matching is a bit different in the way Rust does it than other languages.
Yes, I said that.
Yeah. You said that when it comes to Rust, when you match something, it has to only match one of like the cases.
The matching in Rust is much more advanced, and you can do quite a lot of things. I'm not saying other programming languages can do, but in Rust you can do way much more. So I did cover it in the previous session.
There is something that might be what you remember. I didn't mean to cover it, but I don't think I did. It's that when you've got your data that's being matched, it's got to be exhaustive. Like back in the early example, just a simple example of this one. Like that last one with the wildcard. If that wasn't there, the compiler would throw an error because it's possible that the scrutiny number could be a value higher than 10. And if that's the case, it's not going to be caught by any of them arms. So you've got to have the wildcard, which means everything else,
So
basically.
it requires this.
Yeah, you've got, or you could have a separate condition, as long as you catch every eventuality that can be, it's got to be exhaustive. I mean, and the underscore, the wildcard is your friend there, because that's going to catch everything.
You said at the time because there's another one where if you match, like for example, like one, or for example, if the number or if the thing matches both, like
Right, yeah. I think
it's not allowed. You can only
if
match.
there's more than one option, you mean. It's like the coin. Remember the coin matching sorting analogy that I gave. It'll actually select the first one that it comes to.
And you'll select the first one, but
Yeah.
in Rust it will complain.
Yeah, it will still compile, but it'll actually match with the first one. You can actually see that in the last example I gave about the skiing one. That's actually utilised in that example.
Well, you matches the first one that matches.
The first one it comes to is the one that will be executed. If there's more than one match, it'll execute the first
Rust,
one that it comes to. Yeah.
Because that's also how Bash does it.
There is some scenarios where if you've got an arm that can't be reached, the compiler will give you a warning, but it'll still compile, but it'll give you a warning.
Cool. Be mindful of time, making sure I release you on time. Any more last one? Okay, the last speaker. The best one, right? Okay, just a quick poll. Do you need a toilet break or we're ready to go? Ready to go? Okay, we just